Good afternoon to our audience in Zoom, on YouTube, and to our speaker in Vienna. I am really happy to welcome you to today's talk, Open Knowledge Maps, Visual Discovery for Research Data, presented by Dr. Peter Kraker. Dr. Peter Kraker is the founder and chairman of Open Knowledge Maps, a charitable nonprofit organization which is dedicated to improving the visibility of scientific knowledge for science and society. Peter Kraker is also playing a major role in the GoFair initiative, as he is a member of the executive board of GoFair and chair of the GoFair implementation network on data discovery. In addition, he serves as an expert in the EOSC Task Force Financial Sustainability. In his talk, Peter will address issues related to the visibility of research data and discuss the opportunities of visual systems to increase the discoverability of data sets and data sources. Peter, the stage is yours.
Yeah, thank you very much for the kind introduction. Thank you for the invitation. I'm delighted to present Open Knowledge Maps to you today. And I would like to kick off our webinar with a look at the motivation for our work. And I think the motivation for our work is really well summed up in this image here. There is just too much information out there so that we cannot read it all anymore. And of course, this is very much focused on publications here, but with open science, we now have many new output types available to us, including, of course, and some would argue most importantly, data sets. And so getting and keeping an overview of scientific knowledge has not become only a problem of the magnitude, but also about the complexity of different output types. And of course, this situation was especially on display in the pandemic, but I think we can extrapolate this to any discipline, to any research topic. And another insight, I think, that really came to be known during the pandemic is that interfaces, list-based interfaces are useful for discovery, but they are not able to cover all use cases anymore. In particular, an interface like this one, not able to give an overview of 200,000 results. And it also does not include any data sets. And I think this is now also very well covered in the literature. If we look at studies on research data discovery workflows, we stumble upon quotes like this one. So research data discovery involves making phone calls and looking around in the web and figuring out where I can find the information that I need to answer that particular question. So it's a multi-step process that includes many different modes of discovery. Another quote says, I just search for keywords in Google, prostate, MRI, segmentation, but it is not very effective. I can't remember a single instance when I found something useful. And I think this situation very well shows us how the state of research discovery is at the moment. It was one of the starting points for the GoFair Discovery Implementation Network, because we wanted to improve this situation. And as you can see, there are many champions of fair and open data have joined this network. And one of the first things that we discussed was findability and discoverability. And of course, you all know this by heart, but findability is an attribute of the metadata. In the FAIR principles, we can see that it's all about metadata, and it ends as soon as the metadata are registered and indexed in a searchable resource. But that, of course, could already be the Google search index. Nothing is said about the type of index here. And it could very well be already satisfied for this medical researcher that we've gotten the quote from earlier on. So I think we need a second concept. And the second concept is discoverability. And this is now an attribute of the infrastructure. So we now have findable objects but we also need to have useful search infrastructure, useful search tools around these findable objects so we can actually discover them. And therefore, FAIR is actually just a precondition to discoverability, but it is not a satisfying condition for it to be reached. And we then went out and looked for use cases for this discoverability, and we actually found over 100. So we found that there is a great need for data discovery. There are a lot of use cases that are not satisfied at the moment. And as you can see, there are different areas, for example, metadata for discovery. So for example, this was one use case where there was the idea of a multilingual search for data discovery. Now, of course, we need the objects to have the language then as a metadata property. But a multilingual search, of course, requires a search infrastructure that is able to do this multilingual search, which is a problem in and its own. And I think this is really where findability and discoverability come together. And then we have many different areas such as data citation, overview, linking, documentation, where the users have expressed many different use cases in this matter. Yeah, so we can see discoverability is not very well served in research data. And this was also one of the starting points for us at Open Knowledge Maps. Open Knowledge Maps is a charitable nonprofit organization headquartered in Vienna, Austria, and we're dedicated to dramatically improving the visibility of scientific knowledge, on the one hand for science, but on the other hand, for all the other stakeholders in society. We've seen earlier, not only researchers require data sets. There are many other stakeholders, such as public health officials, for example, and practitioners that require the research data that is being produced. And our approach in Open Knowledge Maps is to use knowledge maps for discovery. And here we can see that they have several advantages over a list-based interface, as that for example, for this topic of heart diseases, we already have sub-areas at a glance, such as risk factors, types of diseases, and prevention. And we have relevant resources, so we can get immediately started. From the theory to the practice, if you go to our website, openknowledgemaps.org, you can create a knowledge map of your own. We have at the moment integrated two main data sources. On the one hand, PubMed, big data source in the life sciences, and on the other hand, BASE, the Bielefeld Academic Search Engine, which now aggregates over 300 million scientific outputs. So you can really search in any discipline. And I've used the example of digital education here. And once you type it in, we then create the knowledge map for you. And as you can see that, like in the example, you have these bubbles which serve as subtopics, such as digital technologies, digital libraries, or down here, digital competence. And once you found an area that you're really interested in, let's say the one on digital transformation down here, you can then zoom into it. You can take a look at the metadata, and in case of publications, if it's an open access document, you can also preview it within the same interface. So that's the current case or use case for publications, but how does it look like for research data? Let's take a look at this live. So here you can, if you click on refine your search, you can actually select the document types, and BASE indexes now over 20 different document types, so books, conference publications, data sets, journal articles, and even software. But let's, of course, stick to research data. And let's take the topic of plastic as an example. And again, the knowledge map is being created. Now the document type is dataset. And we can again see subtopics of these data sets. Oceanography, here we have more chemistry-related subtopics. And down here we also have something on monitoring plastic waste. So that was an area that I was interested in. And I was especially interested in this management part. So you can further narrow it down up here. And it only brings up the data sets that mention the term management. And then you can find and inspect these data sets. And you can also always follow them to the landing page and then download the data set to your computer. So the advantages that we see is that you can get an overview of a search term, of a topic, something that's really difficult to gain. Otherwise, you can identify relevant concepts that are related to your search, which is often the most difficult step in any discovery process, right? What are the actual words that you're going to type into the search engine? You can also sort the relevant from the irrelevant, depending on your information need. So for example, if you're not interested in plastic waste management, but more in oceanography, you can stay within these bubbles and then branch out maybe only data. And finally, Open Knowledge Maps is an interface over all scientific knowledge, so both open and closed, and everything in between, I should mention, but we will always make it very easy to identify the open content and to access it afterwards. How does it work? So for every search, we retrieve the 100 most relevant documents outputs from either Base or PubMed, and the relevancy is defined here by the similarity between your query and the document metadata. And then we put everything onto our servers and we use text similarity to create the knowledge maps more specifically. So we get the API result. Then there is a long pre-processing pipeline that does cleaning, deduplication. There's also a missing subject inference if there are no keywords, for example. And then we create the features, which in this case is the big coword occurrence matrix. And that is then the input for the clustering and the layout algorithm. And then there's also a cluster labeling algorithm based on TF-IDF and a force-directed layout algorithm on the client that creates or unclutters the map. So this is one part, the machine learning AI part, but the other part is of course cognitive science, because visualizations, there are a lot of cognitive aspects that you need to take into account so that users can and actually want to use visualizations. And one of these aspects is of course cognitive load. So our working memory can only deal with a select number of items at one time. So we restrict the number of elements in each view to not overload the working memory. Another effect is, or aspect is change blindness. So at the end of an animation, we don't know how the animation or the scene looked like at the beginning of the animation. And therefore we can often lose the context when we start zooming. And so we use animations only when they are necessary, and we always provide ample context for orientation. And finally, recognition. We use well-known metaphors, real-world representations. So for example, tiny icons of data sets, or the papers look like the icon of a paper and they're not another circle. Yeah, with this approach, we've become the largest visual search engine for research. Over 1.5 million knowledge maps have been created to this date. As you can see, there's a very interesting point here in September 2021, where we went from steady growth to exponential growth. That was, of course, a very interesting time infrastructurally, and it still is, I should say. But it's, of course, amazing to see this kind of adoption and use of the tool. We now welcome over 100,000 monthly visitors, and we also do online and offline workshops that have been attended by over 5,000 participants worldwide. Yeah, we're an open infrastructure in the strictest sense of the word. So all of our services are free and open. Already seen the integrations for Base and PubMed. There's also an open air integration to give you an overview of research projects. We also now have an institutional integration, and that will be the last part of the presentation. But openness, of course, also relates to the fact that our training materials, our source code, our data are all under an open license. And we also keep our community support and engagement programs for free. Yeah, our funding, 60% of it comes from projects. And in these projects, we further develop open knowledge maps to the needs and requirements of specific disciplines or specific corpora. So here in Triple, for example, we looked at the social sciences and the humanities. So this was a big EOS project, which ended in March this year. In Encore, which is an ongoing project together with FU Berlin and Wikidata, we're looking at invasion biology and how to map this field along research questions and hypotheses. And another project that we conducted was with the Austrian Academy of Sciences, where we provided the discovery interfaces to their early proceedings. Yeah, so one part projects and the second part are supporting members. So by now we have 28 organizations on board who support open knowledge maps ideally and financially, and who also co-create the infrastructure together with us. As you can see, it's a rather diverse group of organizations, research institutions, libraries, library networks, publishers, and funding agencies are on board by now. And I think it also shows how important discovery and discoverability have become across the board now. In Germany, of course, we have the ZBW, the German National Library, and the Copernicus Publishing House on board. Yeah, and we generally foster a participatory approach, and we really wanted to fill the words community-owned and community-driven with life. So what does that mean? Of course, community-owned relates to open licenses for content, data, and source code, but in collaboration with community-owned, it also community-driven, it also means that the co-creation of the platform is done together with the community. And for that, we have actually given up control of our technical roadmap. And 1/3 of our technical roadmap is defined by our supporting members, the second third by the wider community, and only the last third stays with open knowledge maps. With that, we really hope to have an equitable balancing of stakeholder needs and to build a basis for the community-based engagement and also the community-based funding, which is where we're transitioning with the supporting membership program. Yeah, and then the last part, and this is, I think, really where this circle really closes, is the easy integration in community infrastructure. And this will be now the last part of my talk, where we'll introduce you to the custom services. The custom services allow you to integrate open knowledge maps into your own offering. This is something that came from our supporting members and is strongly co-created together with them. You can take the knowledge map components, integrate them, restrict them to your own data sources, and everything is available as a cloud platform. So there is no need to install the open source software on your own servers. To give you an example, let's again maybe do a live example here. The aforementioned GoTriple project. The outcome is a search platform that allows you to discover over 10 million documents, over 20,000 projects, and close to 10 million profiles. And you can search here for a topic. Let's, for example, take again digital education as an example. And as you would expect from many discovery platforms, you get a list-based view first, but it's not only limited to this list-based view. There are additional services implemented here, for example, Knowledge Map or our newest visualization type, Stream Graph. But let's look at Knowledge Map first. So this is now based on the GoTriple content. And it shows you, I think, a really nice, or it gives you a really nice overview of the contents of this platform. If you're, for example, a new user and you don't know what to expect, I think typing in your research field and then looking at the results, you will get a very quick understanding of what you can expect here. We see, of course, a strong SSH-driven view of digital education. The technology aspects, for example, are strongly reduced, and it's more about education and also the risks of digitization. Yeah, and everything's neatly included in the interface, and of course, all the interaction elements that you've seen earlier, they're of course also available here in the integrated version. Yeah, so that was the GoTriple integration. Now I want to show you an integration that is specifically focused on data sets, and that is with the Austrian Social Science Data Archive. So they have integrated our search box. Let's maybe go to the bigger version here. So what you can do is that you actually include the full search flow into your interface. You can also set specific default options. So for example, here, of course, a data set is the default and a journal article. And in the background, it's also set from or changed from most relevant to most recent data sets. And we can type in now, for example, labor as an example. And again, we will see the results as a knowledge map. And I think here we have really nice overview. And it's also, I think, much easier parsable than the list. With data sets, we often have titles that are very similar to each other, where a lot of things are repeated, maybe they are panel, and so on. And so just from the list, it can be very difficult to understand what are actually the topics that these data sets are about. But if we look on the left-hand side here onto the knowledge map, I think it's very easy to understand the different topics related to labor that are, that Auster has data sets about. In terms of the technical setup, the idea is that institutions and platforms send their data to one of our aggregators, so mostly based, sometimes also open air. And once we have then access to the data via the aggregator, you can use our APIs to take the components off the shelf and integrate them in your infrastructure. And that can be done within a week or two. So it's really a rather easy process at this point. The first step, of course, sending everything to the aggregator might take a little bit longer, but it also makes your content and your data sets available to not only open knowledge maps, but a wide range of discovery infrastructures that are building on top of these aggregators. Yeah, in terms of use cases, of course, complementing an existing discovery system is the most relevant use case. This can be library catalogs, document search, and so on. Maybe just to give you a bit of an idea of what's happening in the publication-driven world, we can take a look at them a little bit later on, but it's also, of course, also about making resources other than journal articles better visible and better discoverable. And I think with BASE, we have a partner that really indexes a wide range of output types and makes them available in a very nice way. And finally, of course, you can integrate these overviews in all areas of your digital offering. It doesn't have to be a discovery system. It can be a news page. It can be a quiz system. It can be a cultural heritage platform. One example comes from the ETH library. In the ETH library, you can now send any search also to open knowledge maps. So this is the library catalogs discovery that they have. And when you click here on the left-hand side, a knowledge map is created on the same topic. This integration has also been adopted by other universities such as TU Wien, and they have also integrated our newest visualization type called Stream Graph, which I wanted to show you briefly. So let's again use the topic of plastic as an example, and you can then click here on the timeline, and then this will create an overview over time. So here on the x-axis we have the years, and on the y-axis the number of documents with the keyword. And this gives you kind of an understanding of the evolution of a topic over time, such as plastic waste becoming a really big thing. But then, of course, also things like circular economy, so trending topics related to this keyword can be easily found within the stream graph and detected there. Yeah, and then I also talked about integrating open knowledge maps in different areas of your digital platforms. This is an example from University of Lausanne, where you can see their core research topics, and they have done a really nice job in introducing these topics, writing a text about it. There is a video, there are people you can contact, there are news stories, but they also wanted to connect it to their repository, and that is now being done with a knowledge map. So when you click here, a knowledge map is being created that is based on the UNIL repository and gives you an overview of the research outputs of the university related in this case to sport. Yeah, also looking a little bit into the future, what are components that we are developing at the moment? One thing is author maps, so showing not maybe long publication lists, but actually visual representation of the output of an author. Just an example from Arne Bartke, professor at the University of Salzburg, who has for a long time had this on his website. He has the advantage of having a unique identifier as a name, but we're currently working on the ORCID integration so that everyone can actually use this feature. Another feature that's already been enabled is to create maps of research projects. In this case, we're using OpenAIRE as our database, and is in particular the link between projects and the outputs of the project. And this then gives you, I think, a very good overview of what has actually been produced by the project, what are the actual outcomes, which is, of course, in many cases more relevant than the project website, which becomes quickly outdated or may not be available anymore. And it's easier to understand than a really long list of deliverables. Yeah, now we're already at the end of the talk. It's been quite a tour. So what are the take-home points that I would put here at the end? So one, discoverability of research data is seriously lacking. So we've seen in the beginning that this is an area that really needs improvement. But thankfully, visual discovery shows strong promise for research data. It's of course at this point that the tools are still developing, and it's not at sort of the same level as it is for publications. But I think in this collaborative approach that we have, we can really get there. And finally, Open Knowledge Maps is an open and participatory infrastructure that can be easily integrated in new and existing data discovery infrastructure. And we're also looking for new collaboration partners, people who want to drive this idea forward together with us. With that, I want to say thank you for your attention, and I'm really looking forward to your questions and comments.
Thank you to our speaker, Peter Kraker, for this really very interesting talk, and also for the audience on YouTube and Zoom. Many thanks for joining us. And to the audience on YouTube, please also have a look at our next talks and the other events of NFDI on our website. The next InfraTalk will take place on 4th of September about open research knowledge graph, so very much interrelated with today's talk. And now we will be switching to our discussion in Zoom. So after the stream has ended.